A MOS differential amplifier to operate from plus minus 1 voltage power supplies and dissipate no more than 1 milliwatt 1 milliwatts in the equilibrium states. The differential voltage gain AD is to be 10 voltage per voltage, and the output command mode DC voltage is to be 0.2 voltage. This is the DC voltage at the drains. Assume μnCox is equal to 400 microampere per voltage square and neglect the early effects. Specify I, R, D and W over L. Okay, first we are asked to find out the I value. Now you should so notice like we don't have a lot of information to find I value because if you remember the equation of the I is given by half μnCox W over L V over drive square, but we don't have all this available. And when we are calculating I in a differential amplifier, that is like all together. If you this is differential amplifier, mean each side we are going to have current, and that comes together as I. Each side is to be I divided by 2. Okay, now let's see how there's a shortcut we can use here since there's a power provided, because we know that power is nothing but P is equal to V times I. Okay, so we are interested in I is P divided by V. So here we have to just look at what is the P we have. So we have the P is to be 1 millivoltage, but the P is just the P, but for the voltage we are going to have the drain voltage and the source voltage. Both of them are 1 voltage as it mentioned right here. The power supplies are this. It means VDD and the VSS is going to be 1 voltage. So this is going to be P over 1 plus 1, and P also we can plug, that is 1 milliwatts. So that is 1 milli over 2. 1 milli over 2, that is 0.5 milliampere. So that's the total current. Okay, that's the I value. Then they're asking us to find out the RD value. This is our first answer for the question, and then we have to find out RD. To find out the RD, we need to know the gain and the transconductance GM. The gain is readily available 10, but GM we don't know. In order to calculate GM, we can use this equation. GM is equal to 2 ID divided by V over tri. But do we know the ID? Drain current is like, if you look at a differential amplifier, it has two sides current flow and come together as the total current flow, that is this I. Each side is I divided by 2. Okay, so it means if you have 0.25, that one should be divided by 2. So this is also equal to 2 I divided by 2 over V over tri. So 2 to cancel. Finally we will get the expression of I over V over tri. We know the I value, but we don't know the V over tri, so we cannot substitute yet because we had to figure out what's the V over tri is. Okay, and V over tri is nothing but V input differential divided by square root of 2. Now we don't have the input differential as well, so we have to calculate that one. And input differential, there's a gain equation that is also related to input differential, that is the V output divided by V input differential should be equal to the gain, and we know the gain 10. V output is provided right here. Here they mention the output common mode DC voltage is to be 0.2 voltage. This is the output voltage, so 0.2 divided by VID is this. So if you rearrange this one, this VID is equal to 0.2 divided by 10, which is equal to 0.02 voltage. Now once we have the VID, we can find out the V overdrive, that is VID divided by square root of 2, 0.02 divided by square root of 2, and that will give us 14.14 millivoltage. Okay, now once we have the V overdrive, now we can find out the GM value, because GM is I over V overdrive. GM is I divided by V overdrive, and I we just calculated, that is 0.5 milli, and V overdrive is 14.14 milli. And if you plug this and calculate, you're gonna get 35.36 milliampere per voltage. Okay, milliampere per voltage. So this is what we are getting. Okay, so once we have this, the next one, the main thing we are trying to find is RD. We did all this to find out RD. RD is AD over GM. Let's use this in the next one. RD is equal to AD over GM. AD is readily available, 10, and GM is the one we did a lot of steps to find that one out, that is 35.36 milli. And if you solve for it, you are going to get 282.81 ohm resistance. Okay, and once we have RD, the next one is we have to find out W over L. To calculate the W over L, you can use either current equation or the transconducting equation. Transconducting equation is much simpler, because if you look at the transconducting equation, that is given by Kn prime W over L V over drive. Okay, here we are understanding W over L. So if we rearrange this equation in terms of that, that is Gm divided by Kn prime times V over drive. We have all the values available. Gm we just calculated, that would be 35.36 milli, 35.36 milli, and the Kn prime is given in the question, that is 400. Kn prime is nothing but μnCox, so that is equal to 400 microampere per voltage square. So 400 micro, and then V over drive we calculated here 14.14 milli. Okay, milli cancels, and this one divided by this value, and if you calculate this one, you're going to get 6,251.77, and that's the ratio, width over length, so there's no unit for it. And that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.